Hello guys, welcome back to my YouTube channel. Today we are going to solve day 28 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now, without any delay, let's get started with today's problem. Problem number 2290. Minimum obstacle removal to reach corner. Okay. So in this problem, you are given a 0 index 2D integer array grid of size m into n. Each cell has one of the two values, 0 or 1. Okay, 0 represents an empty cell and 1 represents an obstacle that may be removed. You can move up, down, left or right from and to an empty cell. Okay, we have to return the minimum number of obstacles to remove, so you can move from the upper left corner to the lower right corner. Okay, so see this example number 1. So initially this is your source and this is your destination. Okay, so you can move in 4 directions. Okay, possible. So here if you are at this particular cell, then you can move to this direction or you can move to this direction. Okay, these are the only two options. We can't move here and here, right? This is out of bound, right? So there is no possibility, right? So we have only two options. Okay, and we so you can see here there is one obstacle, right? There is one obstacle here. Okay, so um, we are representing obstacle with 1, right? So here I can draw it like this. Okay, so this is the grid, right? And initially you are at this position and you want to reach here, right? And here there is one obstacle, there is one obstacle here, there is one obstacle here, there is one obstacle here, one obstacle here, one obstacle here, and here this side is 0. Okay, and this is your destination. Okay, so here you have two possibilities. You can move to this direction or you can move to this direction. Okay, so here let me just give the indexing 0 1 2 0 1 and 2. Okay, so from cell 0 by 0, okay, you have two possibilities. You can move to the cell 0 and 1. Okay, this is one possibility, or you can move to the cell 1 0. Okay, these two are the possibilities that we have. Okay, so here if I move from 0 to 0 to 0 to 1, okay, so there is one obstacle. Okay, so here let's say I'm writing the weight. Okay, so this is the cost. Okay, so weight of this edge. Okay, let's say this is one edge. Okay, and these are the nodes containing the cell positions. Okay, so here if I'm moving from this cell to this cell, total weight is 1. Okay, total edge weight is 1. And if I'm moving from this cell to this cell, okay, then again total weight is 1. Okay, this is done. Now if you are at this cell, okay, let's say, then you have two possibilities. Okay, so you can move to this direction, you can move to this direction, and you can also move to this direction, but it doesn't make any sense. Okay, we are moving back to our source, right? We have already wasted this, so it doesn't make any sense. So let's say from 0 1 you can move to 0 2, okay, this cell, or you can move to 1 1. Okay, these two are the options that we have. Okay, so if you move from 0 1, okay, this cell to this cell, then again total weight here of this edge is 1. And if you move in this direction, then also the weight is 1. Okay, right? So now let's say you reach at this position. Okay, you reach at this position. Okay, 0 2. Okay, so from here you can move to two options. You can move to this direction or this direction. Okay, so we are not going to move back. Okay, doesn't make any sense. Okay, so from 0 to, let's say I move to this 1 2. Okay, this cell 1 and 2. So cost of this cell is 0 only, because there is no obstacle, so there is no cost here. Okay, so 0 2 1 to 2, there is no cost. Okay, then after that, let's say that I move to this cell. Okay, so if I move to this cell, that simply means 2 to 2, and this is where I want to reach, right? So here in this example, a total number of rows I have is 3, and total number of columns that I have is 3. Okay, so I want to reach to this position only, right? M minus 1, R minus 1. Okay, and here also cost is 0, right? This cell is empty only, this destination is empty only, right? So right, so here this is okay. So here from source, okay, this is my source and this is my destination. So what is the total edge weight? Okay, total obstacles that I'm removing. So total edge weights, okay, so 1 2 and 2. Yes, total 2 obstacles that I will move in the path. Okay, same way we calculate from this path as well. From this path as well we will calculate, okay, whatever the possibilities we have. Okay, so here I am treating my cells as nodes. Okay, I am treating the obstacles as weight. Okay, so this is what this is nothing but a graph. Okay, this is what nothing but a graph that I'm preparing. Okay, and here what we are doing, we are moving from source to destination, right? And the edges have weight as well, right? Edges have weight, right? Edges have weight as well, right? And what we are finding, we are finding the minimum number of cycles that we want to remove, okay, by moving from source to destination, right? So here, from here, one thing is clear, that I can implement here nothing but Dijkstra's algorithm, okay, Dijkstra's algorithm, okay, and I can also implement here BFS as well, okay, 01 BFS, okay. So in this today's tutorial, I'm going to solve both the approaches, okay, going to solve this problem using both the approaches, Dijkstra's and 01 BFS, okay. So now here we know that we edges have weight, okay, and we want to find move from the source to the destination, right? So what I'm going to do here, okay, so how our Dijkstra's algorithm work actually? So in Dijkstra's algorithm, what we do, so let's say we have one source to destination we want to move, okay. So we want to move from our source, okay, which is starting position, let's say this, okay, to my destination, okay. So here let's say this is 0 index, this is 1, this node value is 2, let's say 3, 4 and 5, okay. So what do you calculate? Okay, so you calculate like 0 to 1. If I move, then I have to write the minimum cost, okay, or minimum weight or minimum distance, okay. So okay, so if you move from 0 to, you want to write the shortest distance, okay. If you move from 0 to 0 to 3, you want to move, so you will write the shortest, okay. So 0 0 0 only, and here let's say initially all the values are infinity. So this is what we did in the yesterday solve problem, right? So if you want to move from 0 to 1, you have to write the minimum distance here, okay. If you want to move from 0 to 2, you have to write the minimum distance here, let's say 2, here let's say 1, okay, here 3, here 3, okay, let's say. So in the end, you get the value, final value here, okay, 0 to 5, minimum distance here, something, okay, some value. So this is what we do, okay. But here we have this matrix type values given to us, okay. So we are not going to construct a 1D array, we are going to construct a 2D array, okay, because we don't have values like this 0 to 1 I'm moving, then 1 to 2 I'm moving, but instead of this we have cells, okay, 0 by 0, from 0 by 0 I'm moving to 0 by 1, okay, like this we have things, okay. So for that purpose I'm just going to prepare a 2D array, okay. So here this is what how my 2D array is going to look, okay, 0 1 2 0 1 2, and here inside this initially I'm just going to set all the values to infinity, okay, all this are set to infinity. I have to find the shortest distance, okay, or minimum number of obstacles, okay, with the in that part, okay. So here this is going to be my source, right, and this is going to be my destination, okay. So from here I have to move this direction or this direction. If I reach here, then this direction or this direction, okay. All these things I have to check, okay. And we have to use priority queue as well, okay. Mean heap, I'm going to create a mean heap, okay. So in mean heap what we do, we add the weight, okay, we add the weight, and then we have to add the destination, okay. So to this destination, if I am moving from source, then what is the minimum weight, weight that is coming up, okay. So minimum weight we are always going to put in the top, but here this destination is going to be of cell type, okay, having I and j values. So here I'm just going to write I and j, something like that, okay. So this is what I'm going to do, okay. So I'm going to explain all these things, okay, while writing the code. So let's move to the coding part side by side, okay. Let's write the directions, okay. So private final int directions, okay. And we have four directions, right? So here let's say if I'm at this position, okay, and here from here if I'm moving to the right, okay. So if I'm moving to the right, that simply means that I am incrementing the column, okay. So let's say this is 0 by 0. So if I'm moving to the right, so that means that I am incrementing the column and my row will remain same, right? So if this is okay, matrix given to us, let's say, and you are here, let's say, okay. So if you are moving here, so you are remaining in the same row and your column is incremented, okay. So this is nothing but my right, okay. And if you move to this side, then your column is decremented, okay, and your row remains same. So this is nothing but my left, okay. And if you move up, then your row is decremented, okay, row is decremented and column remains same. And if you move down, your row is incremented by 1 and column remains same, okay. So this is nothing but down and this is nothing but up, okay. So this is what I need to write here. So here inside this 0 comma 1, so I hope that this is clear, okay. And then 0 comma minus 1, and after that 1 comma 0, then after this minus 1 comma 0, okay. So these are the directions that we have, okay, done. All right, so now once this is done, then after that you can do one thing. Let's write it outside this. Okay, so let's write it outside, and now inside this your main method. Okay, so here let's first count the number of rows and columns we have. So int m is equal to grid dot length. Okay, n is equal to grid of 0 dot length. Okay, and now create one 2D array for min obstacles. Okay, min obstacles is equal to new int m and n. All right, now we have to initialize all cells with a large value representing unvisited cells. Okay, so here what I'm going to do, for run one loop for int I is equal to 0, I is less than m I plus plus, for int j is equal to 0, j is less than n, j plus plus. Okay, and I'm going to fill all these min obstacles with the integer dot max value. Okay, in the starting min obstacles. Okay, I j as integer dot max underscore value. Okay, and once this is done, okay, then after that let me just format. Okay, so this is a common code that we are going to use for both approaches. Okay, until here. All right, now after that, from here, first let's solve this problem using the Dijkstra's algorithm. So initially we put this as a source. Okay, so from source to source, total 0 value is going to 0 only, right? So here just going to write min obstacles. Okay, 0 0 is equal to grid of 0 and 0 value. Okay, so here you can directly give 0 only, because this value is always set to 0, I think. Yes, right, grid 0 by 0 is always set to 0, so you can simply write 0 here. Okay, no issues, this is given in the code. Okay, constants. All right, now after that we have to use priority queue, right? So here priority queue. Okay, and in priority queue we are just going to add the array, right? Int pq is equal to new priority queue. Okay, and let's say we have two parameters a and b. Okay, so we have to implement the min heap based on the value which is at first position. Okay, 0 index, so a of 0 minus b of 0. Okay, this is done. Then after that we have to add the starting cell to the priority queue. So pq dot add starting cell we have to add. Okay, new int. Okay, and here what we are going to add, we are just going to add min obstacles at 0 by 0. Okay, this is nothing but you can say weight or obstacles. Okay, so this min obstacles. Okay, and starting cell is 0 and 0. Okay, three values I'm passing, right? I and j cell. This is done. Okay, now we have to run one while loop. Okay, same thing that we usually do in all the Dijkstra's algorithm, right? Same thing I'm doing. So yesterday also I solved this problem. Okay, some similar problem in which I have implemented same thing, right? Is empty. All right, and here we are just going to process the cell with the fewest obstacles removed so far. So first thing, let's write current. Okay, current, just remove it, pq.poll. Okay, right now only we have this one. Okay, on the top. So what we are going to do, we are going to process the cell with the fewest obstacles removed so far, that we are going to process first. All right, so here in this current we have obstacles at 0 index, we have row value at 1 index, we have column value at index 2. Okay, so int obstacles. Okay, int obstacles is equal to current of 0. All right, and row is equal to current of 1, and after that column is equal to current of 2. Okay, so this is done. Now if we reach to the end, okay, one base condition, if we reach to the end, then just return the obstacles that we have counted so far. Okay, so if row is equal to m minus 1 and column is equal to n minus 1. Okay, so here return obstacles. Okay, now once this is done, okay, this is done here, right? And then after that uh, we have to explore all the 4 possible directions from the current cell. Okay, so for that purpose only I have created this directions array. Okay, so here I'm just going to write for int directions. Okay, now inside this new row, new column we need, right? So how I'm going to write new row? Okay, I'm moving to the new row from my current position. Okay, so I told you that in my row. Okay, so let's say I am here, and if I want to move to the right side, so what I'm going to do in this, okay, in this uh, 0, okay, 0 0, we have two values, 0 and 0. Okay, and if I want to move to the new row, okay, so what I'm going to do, I'm just going to add this value and this value. Okay, so in my new row I'm going to add 0. 0 is coming from here. Okay, this 0 by 0 is this one, and if I want to move to new row, so I have to add 0 with this 0, I get 0, and I have to add 1 here to get a new row. Okay, so here I will get this 0 1. Okay, 0 1 is nothing but my new total new cell. Okay, so new row is equal to row plus direct this. Okay, and new col is equal to col plus. All right, done. Then after that just check if that particular cell is valid or not. Okay, so if is valid, and here I'm going to call this method, okay, is valid. So here I'm just going to pass the grid. Okay, and I'm going to pass the new cell values. Okay, new row and new code. Okay, so I'm going to write it later. Okay, this method. Okay, so now if it is valid, then we have to calculate the obstacles removed if moving to the new cell. Okay, so new obstacles is equal to new obstacles is equal to the obstacles that we have counted so far, and if there is any obstacle present in the new row and new column. Okay, new row, new column. Okay, now after that, okay, we have to update if we have found a path with fewer obstacles to the new cell. Okay, so here just one if condition. Okay, if new obstacles, okay, is less than the mean obstacles that is already there. Okay, mean obstacles at this new row and new column. Okay, if this is the case. Okay, so initially you know that we set all these to infinity only. Okay, so if later on, let's say I found that we are reaching here with two obstacles, and later on from here, let's say if I come, okay, in from this path, okay, from here one obstacle, from here one obstacle, total two obstacles. But let's say if there is one obstacle here, one obstacle here, then one obstacle here, then I reach here, so I get the value 3. So I don't need to write 3 here then. Okay, because this is minimum only, okay, to this cell. So here if new obstacles is less than this mean obstacles new row new call, only then I have to update. Okay, so what I have to update, I have to update this is equal to new obstacles. Okay, and then we have to add the same thing to our queue. New int. Okay, and what we are going to pass, we are going to pass here new obstacles, new row, and we are going to pass new core. Okay, that's it. All right, this is done, and in the end we are just going to return. Okay, so here this ends, and we are just going to end return here, return mean obstacles at m-1 n-1. Okay, and my destination. So that's what we need to do. That's it, right? Now only one thing is pending, that is nothing but our helper method. Okay, so this helper method is going to be very easy. This is valid. Okay, so now let's do that. Private boolean is valid. Okay, and in this I'm just going to pass grid, row, and I'm going to pass column. Okay, and from here simply I'm going to return false. Okay, if return, okay, row should be greater than 0, okay, only then I have to return true. Okay, row should be greater than equal to 0. Okay, and column should be greater than equal to 0, and row should be less than grid dot length, and column should be less than my grid of 0 dot length. Okay, and yeah, that's it. Okay, so if this is true, then it is going to return true, otherwise false. Okay, and yeah, that's it. So now let's run it and see if there are code issues, then we try to fix that. So nice, so the test case has been accepted. Now let's submit it. So see, our solution is accepted, right? Okay, so let's see if we can see the time complexity from here or not. So yes, we can see the time complexity. So time complexity is going to be m into n, and then log mn into n. This is because we are using priority queue. Okay, log m into n, and this is nothing but for all the cells that we are moving m into n, right? So we can actually remove this. We can actually remove this log m into n if we don't use the priority queue, right? So here, instead of that, we can solve this problem using this 01 BFS. Okay, so here if you see, we are here. Okay, and 145 milliseconds, and we are here. Okay, so now let's try to solve this problem using DQ. Okay, so for that, just few things we need to change. Okay, nothing much. So here, just let me do one thing here. Just I'm going to remove this part only. Okay, so this thing I'm going to remove. All right, so until here I'm going to remove. Okay, let's say, yeah, that's it. Okay, so now here, uh, what we are going to do, now we have to use DQ. Okay, so in DQ how it is going to work, I will show you that. Okay, so here DQ I'm taking. Okay, and here int DQ is equal to new array DQ. All right, so now here, in the DQ, first we are just going to add the initial where we are present. Okay, so DQ dot add a new int. Okay, and we are present at this position. Okay, 0, obstacles are 0. 0 is the number of rows, 0 is the index of the my current row, and 0 is the index of my current column. Okay, so here I am at this position right now. Okay, so now once this is done, okay, now after that, just same thing. Okay, whatever we did in priority. Okay, so while my DQ is not empty. Okay, DQ is not empty. Okay, until then we have to apply few operations. Okay, now inside this, same thing that we did in the priority queue, current is equal to dq dot poll. Okay, now same thing we have to write here as well, int obstacles is equal to current of 0. Okay, int row is equal to current of 1, column is equal to current of 2. Okay, so here let's move to all the directions. Okay, same code. Okay, whatever I've written, but I'm just going to use dq now. So int directions. Okay, and here new row is equal to row plus direction at 0. Okay, new call is equal to call plus direction at 1 index. Okay, this is done. Now here I'm just going to check if same thing is valid. Okay, and here I'm just going to write grid new row new column. Okay, and here we have to check one more thing, that mean obstacles new row, new column. Okay, if it is equal to integer dot max underscore value. Okay, this is done. Okay, then in that case we have to check if there is obstacle present. Okay, so here I'm just going to write if grid of new row, new column. Okay, if it is equal to 1, then in that case if it is an obstacle, then we have to add 1 to obstacles and push to the back. Okay, push to the back I'm saying here. Okay, so here min obstacles, new row, new column. Okay, I'm adding the obstacle to this here. Okay, obstacles plus 1. Okay, and now here see carefully dq dot add last. Okay, if there is obstacles, then I'm adding to the last position. Okay, in the my dq dot add last, new int. Okay, so here obstacles plus 1. Okay, and here new row, and here new column. Okay, this is done. All right. Okay, so here in the else part, now I'm just going to copy it. Okay, but I'm going to do a little bit change. Okay, so if there is an obstacle, then my min obstacle new row new column will remain same. Okay, this is going to remain same. And now if there is no obstacle, then instead of adding to the last, I'm going to add to the first. Okay, and here I'm not going to add 1 to here. Okay, and I'm going to pass the same thing, new row new column. Okay, that's it. And then yeah, that's it. Okay, that's what we need to write. Now let's run the code and see if there are code issues. So yes, so here let's fix that. Int obstacles is equal to current of 0. I am writing int here. Okay, so all the test cases has been accepted. Now let's submit it. So see, our solution is accepted. Now this is just 55 milliseconds. Okay, so that is why the time complexity for this part is mainly mainly going to be m into n. Okay, for this particular problem. Okay, since we are iterating over all the cells. Okay, that we have added in my DQ. Okay, so that's it. So I hope that you guys are clear with both the approaches, and if you guys still having doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. We'll see you guys in the next video. Thank you. Bye bye.